Hi, I'm Austin Dillon with Pierce Phelps. Thanks for taking the time to watch this video. Today, we're discussing the MUR horizontal discharge heat pump from Carrier Bryant. This video will serve as an overview of the installation until such a time that we complete our full installation video. Looking at the system, we'll hit these bullet points real quickly and then move on. It's currently available for purchase through Pierce Phelps. We are selling the AB outdoor unit, which is high heat standard, as you can see, delivering approximately 100%, some cases a little more or less, at 5 degrees. And first, we're going to look at it in the context of an installation with its matched air handler, the 40 MUA. And then we'll move on to look at some combinations with gas furnaces, conventional air handlers. It's 24-volt thermostat operated, uses the same electric heat package as the 40 MBAB. If we're familiar with that, it's the eork. The indoor and outdoor equipment are powered separately. One of the big deals here is that it uses conventional line set sizes and actually allows for the reuse of existing line sets. Refrigerant metering occurs at the indoor equipment, so whether that's this 40 MUA air handler equipped with an electronic expansion valve, or whether that's a conventional piece equipped with TXV or some other type of metering device, that native metering device will be used. Again, since the metering device is inside, the liquid line does not require insulation, and thus, again, we can use or reuse existing line sets. The outdoor unit has its own 24-volt defrost control, which allows it to be paired with non-communicating or conventional indoor equipment, and the outdoor unit has a diagnostic display. You'll notice that the outdoor unit ships with flexible mechanical connections, and this is because the outdoor unit connection size, again, is conventional, and our flaring tools likely will not facilitate those sizes. So the sizes will be 3/8 and 3/4, all the way up to 4 ton, and then the 5-ton unit will utilize 3/8 and 7/8. If you get the 40 MUA air handler for your installation, it will come with its own pair of those flexible mechanical connectors as well. And they are mechanically fit here at the unit, and then you braze here. It's recommended to install a liquid line filter dryer on these systems. They are heat pumps, so they would require a heat pump style filter dryer. However, they do not ship with the equipment. They would be field provided. So again, looking at the initial installation in the context of a 40 MUA air handler and a 38 MUR horizontal discharge heat pump outside, we've got some different options for wiring the outdoor equipment to the indoor equipment. Now, we've already said that both the indoor and outdoor equipment will receive their high voltage power independently. So we're going to have 2 circuits. But when it comes to the wiring or low voltage or communication wiring that occurs between the indoor and outdoor equipment, we've got a couple of different options. So again, this applies only to the 40 MUA air handler inside. We'll look at conventional equipment inside a little bit later. So the first thing that we're going to want to do is determine how we want to wire our indoor unit to our outdoor unit. We've basically got 2 options. We can do 2-wire communicating, or we can do conventional 24-volt thermostat wiring using 18-gauge thermostat wire. So coming back to option number 1, 2-wire communicating. Sounds appealing. However, it is going to require that the wiring between the indoor and outdoor equipment be 16-2 stranded shielded wire. So that being the case, it may be a little bit more enticing to use the 24-volt method, which is going to use standard 18-gauge thermostat wire and is likely already existing. If this is a change-out opportunity, that wiring is very likely already there. This would, in almost all instances, I would imagine, require a wire pull. So we're going to pick one of these 2 options, and there are dip switches at both the outdoor and indoor equipment that are going to need to be set to dictate which of these 2 options we want to utilize. I'll show these again as we go through, but real quickly, if I want to use the 2-wire communication method, option number 1 here, I don't need to touch any dip switches. All of the dip switches at the outdoor equipment will be left off. If I wanted to use 24-volt conventional thermostat wiring, dip switch number 2 of that bank would be turned up or into the on position. So again, looking at option number 1, 2-wire communication. We already said it's going to require 16 two-stranded shielded wire, and that's going to be landed on the outdoor unit on S1 and S2. We're going to look at these terminals a little bit closer here in a bit, but S1 and S2 are the top 2 most left terminals, and that's indicated by the terminal block designations up above. So it's very easy to confuse RC. We're going to see this in the next instance, but very easy to confuse the S1 and S2 terminals with R and C. These terminals are not R and C, they are S1 and S2. R and C, as indicated by this diagram, are below them, here and here. And then S1 and S2 at our indoor equipment. And this is landed on the main printed circuit board, not on the 24-volt interface. The 24-volt interface faces forward in the cabinet, and the main PCB faces sideways. And these 2 terminals are at the front bottom. So that's where you would make the connection when using this method. All right, option number 2, 24-volt thermostat wiring between the indoor and outdoor equipment. You're going to need a minimum of 5 conductors and 18-gauge thermostat wire, industry standard. So on the outdoor equipment, we already mentioned, we would turn the second dip switch to the on position. On the indoor equipment, we're going to turn the 4th dip switch to the on position. This diagram shows the 1st dip switch being on as well. We're going to discuss that a little bit later. It doesn't totally apply here, but I'll explain what that means here in a little bit. So if we're interested in using 24-volt conventional wiring between our indoor and outdoor equipment, again, probably the most common scenario, we're going to turn dip switch number 2 on at the outdoor equipment. We're going to turn dip switch number 4 on the first bank of dip switches. So technically this is SW1-4, needs to be turned to the on position. So looking at the terminals on the outdoor equipment in the context of 24-volt conventional wiring, again, we want to really make sure that we are understanding that S1 and S2 are the top 2 and R and C are the bottom 2. If we accidentally land 24-volt power on S1 and S2, we will damage this board and it will require replacement. So in this second method, these top 2 terminals are not being used. R and C, again, as indicated by this diagram, are the bottom 2 left terminals. So just to real quickly give you the functionality of these terminals, this is not difficult. It's very similar to a conventional heat pump. However, there are just a few minor details that need to be discussed. So, of course, R and C are your 24-volt hot and common. I'm probably going to use red and blue for that. Y1 and Y2. This is not a 2-stage piece of equipment. This is an inverter-driven variable speed piece of equipment. However, the 24-volt inputs can give it some idea of how hard it needs to be working or how far away from set point it is, how aggressive it should be, and it's an attempt to address the cooling call. If you have the conductors and a thermostat that facilitates 2-stage, feel free to configure your thermostat as a 2-stage compressor and wire both. In most cases, however, you'll likely configure it as a single-stage heat pump, probably a 2-heat, 1-cool heat pump if you have backup heat, in which case you should land your Y wire on the Y2 terminal. And you can almost imagine this, although it's not printed out here this way, you should probably imagine it like it's the Y/Y2 terminal. And that's something that we're familiar with equipment for, the last several years in the field. B is the reversing valve terminal. So instead of an O or an OB like we're used to, we're only using B. So again, that would be this terminal right here. And it is energized in the heating mode. The default methodology for heat pump thermostat is to energize in the cooling mode. So you're going to need to reconfigure your heat pump thermostat to energize the reversing valve in the heating mode. But the B terminal is where you will land your reversing valve wire. In all likelihood, it's probably still going to be an orange wire. D is what we are probably used to seeing as W. This is the terminal that energizes during defrost to send a call for backup heat into the indoor unit. Conventionally, W would have been that terminal. So we want to make sure that we're recognizing that D is the defrost terminal the terminal that energizes to bring on backup heat, because there is a W terminal. It is not used. And if we wire it to this terminal, we will not get the desired functionality. So W terminal is not used on this piece of equipment. And instead, the D is the defrost terminal, and that would wire back to our indoor piece of equipment to bring on backup heat during defrost. And L, for all intents and purposes, can be ignored as well. It's not going to be used for most of our installations. So again, we're going to have RC, Y2, B for reversing valve, and D for 24-volt output for backup heat during defrost. So 1, 2, 3, 4, 5 18-gauge thermostat wires are going to be required to make this installation work. All right. Once we have determined how we want to wire our air handler to our outdoor unit from a low voltage perspective, we then want to determine whether we want to use a 24-volt thermostat or whether we want to use a proprietary wired controller with this unit. We are recommending that you use a 24-volt thermostat. The unit does not ship with a controller. You would need to order the wired proprietary controller separately. But again, we're going to recommend a 24-volt thermostat for these installations. So if we do use a 24-volt conventional thermostat configured as a heat pump, we are going to turn on the indoor 24-volt interface board SW11 to the on position, and that's the dip switch that we saw in our earlier example. If we want to use the wired controller, again, not recommended. However, it's your prerogative. If we so choose to do that, we would leave that dip switch in the off position. So real quickly, I want to review the functionality of the terminals at the indoor board, the 24-volt interface board. Very similar to the outdoor board, but a few nuances that we want to be aware of. Very similar to a conventional heat pump with a couple of minor changes. So again, we have R and C, 24-volt hot and common. We have L, which we are not going to be using. We have G for blower, pretty straightforward. Here we have Y1, and they did label it Y/Y2. Again, if we're configuring the heat pump as single stage compressor, definitely going to want to use Y/Y2. If you have a thermostat and the wires to facilitate two-stage compressor, you are more than welcome to do that. You should use Y1 and Y2 respectively. Again, B is our reversing valve terminal, and the thermostat should be configured to energize that reversing valve in the heating mode. W is not used. AUX and E, as of now, are not used. Instead, if you have a backup heat source and a backup electric heat package, you are going to either use W1 or W2. Out of the box, these two terminals are digitally jumped through the board. So they're coupled together, and it doesn't matter which one you landed on. You're going to get the same functionality out of both of them. I'll show this in a little bit, but if you have a large enough heat package that it is staged and you have a thermostat that facilitates that operation, then you can decouple them using this dip switch, and then you can bring on W1 and W2 independently for different stages of your backup heat source. But again, W is not used. AUX E is not used. W1 and W2 are your calls for backup electric heat. If you so choose to use the wired controller, you wire it using 18-gauge thermostat wire. It is not polarity sensitive, and you will connect two wires to HA and HB on the wire controller shown here, and then you will connect two wires to HA and HB on the 24-volt interface of the air handler shown here. They are not polarity sensitive, so you don't have to keep the wire straight. And it is just simply 18-gauge thermostat wire. So to put the low voltage wiring kind of all together in one slide, I think this is a useful slide here. There's some information missing currently from the installation manual that we've tried to put into this slide. So overall, we've kind of got three ways to wire the system. In scenario one, I use a 24-volt thermostat, but I use two-wire communication between the indoor and outdoor air handler. So we're going to look at scenario one and review it again real quickly. One of the problems with the installation manual does not show terminal to terminal wiring. It shows block wiring. So it's just simply showing you that you're going to use the 24-volt block of the indoor and outdoor equipment, but it does not show specific. So that's why we take the time to outline the functionality of each one of the terminals prior to looking at this slide. Hopefully you're familiar with that at this point. You can, of course, go back to reference it. So in this instance, 24-volt thermostat, 2-wire comm. Here's our 24-volt thermostat connections, and then our 2-wire communication, which we've already talked about. And then we've got 2 banks of dip switches, one at the indoor unit and one at the outdoor unit. Again, this is a little bit of a shortcoming of the installation manual because it only shows you the outdoor unit dip switch bank in the installation manual. I have added, it only shows you the indoor unit dip switch bank in the installation manual. I have added the outdoor unit dip switch bank. But to further confuse things, it shows the indoor unit dip switch bank next to the outdoor unit. So for the purposes of this slide, SW1 is our indoor unit dip switch bank, and S1 is our outdoor unit dip switch bank. So for scenario number 1, S1 and S2 between the indoor and outdoor equipment, 24-volt thermostat wiring between the 24-volt thermostat and the air handler. And everything is essentially, SW1 of the indoor unit is turned on to facilitate that 24-volt thermostat control. Second scenario, 2-wire controller and 2-wire communication between the indoor and the outdoor equipment. So again, scenario number 2 here. On our outdoor equipment, we don't touch any of the dip switches. On our indoor equipment, we're turning SW14 to the on position. And of course, we're just going to run 2 wires between the air handler and the wire controller, and 2 wires between the air handler and the outdoor unit. And then finally, looking at scenario number 3, in all likelihood, the most common scenario that you're going to come across. In this case, we are using 24-volt thermostat wiring between the indoor and outdoor equipment and between the thermostat and air handler. So again, this is the most likely scenario for changeouts where the 24-volt wiring, the 18-gauge wire has already been run. There's an existing line set. We're just removing old equipment and installing new equipment. So to look at the dip switches real quickly, the indoor equipment, SW1 and SW4 will be turned on, and on the outdoor equipment, SW2 will be turned on. And then we make our 24-volt connections between our thermostat and indoor equipment according to the terminal functionality outlined previously. And we make those same 24-volt connections between the indoor and outdoor equipment according to the functionality that we defined previously. So that is the low voltage wiring and dip switch setup for the 38 MUR outdoor horizontal discharge heat pump and the 40 MUA proprietary air handler. Look at some additional functionality associated with the boards in the unit for low voltage wiring, and then we'll look at a couple examples of using the 38 MUR outdoor unit with conventional indoor equipment, which it is designed and rated for. So the main PCB, which we already said, sits sideways in the unit, has some green blocks which slide on and off pins, and we can connect wiring to. There's a rotary dial which should not be touched and is held in place with a piece of glue or caulk so that it does not move in shipping. And that dictates or tells the piece of equipment what size it is. And these units are or come out of the box with airflow already set. So looking again, those, I'll go back real quickly, these 3 green sliders, and you'll see that we use the outermost terminals. CN33 is a dry contact, which can have 24-volt power fed into it. If there's an alarm condition, the contacts will close. 24-volt could go out to a provided alarm, field provided alarm, excuse me. So there's no functionality associated with this. This is all field provided, not very common. Work contacts. This one is likely more common. It's a dry contact that's going to close when the blower is in operation. So you would feed voltage into it. If the blower is running, it's interlocked to the blower, it'll close, and you'll have 24-volt output. You could use this for a humidifier, EAC, UV light, something like that. We've also got a water switch alarm, which is the circuit is by default held closed by a jumper right behind it, J1. We'll go back, we'll see if we can see that jumper. There it is right there. That also comes with a little bit of caulk or glue on it so that it doesn't come off in shipping. Again, if it were to be removed and nothing was on this circuit, the board would read that as an open condensate safety circuit. You would get a fault code and the equipment would not operate. So we're going to flick that glue off of there with a little wiring screwdriver. We can then remove that jumper. And then at that point, this circuit is ready to have our safeties tied into it. That could be a wet switch, condensate switch. You could wire them in series. But that's the functionality for the water switch level. And then lastly, we have two screw terminals, UV LED output CN43, which are again interlocked to the blower operation. However, this time they are not dry contacts. They're going to put out a 24-volt hot and common. So that would do pilot duty for a relay or contactor that would then feed power to a UV or LED device. Not going to go into the additional dip switches here. Again, here's SW1. These are the ones that we're going to be concerned about. You're going to see some additional dip switches. I'll just give you a brief overview of what they're there to do. Now, when we use a 24-volt thermostat and configure it as a heat pump, we're going to go through and configure a number of different parameters pertaining to that heat pump, a lot of them having to do with backup heat operation. The wired controller will not have parameters built into it. There's no installer menu, so to speak, where you can configure that controller. Instead, you would change those parameters via these dip switches, and they would ask for temperature swings, outdoor temperature, balance points, etc. So that's what those are for. If you're using the 24-volt thermostat, which is recommended, you will not need to configure those dip switches. All right, looking at the 38 MUR and now in the context of being paired with a cased coil and furnace or a conventional air handler like maybe an FJ, previously FVs and FBs. These are tested, rated with those combinations. So we'll briefly look at what the configuration and wiring would look like for those. So here we are. Paired with a single stage furnace. So the outdoor equipment is still our 38 MUR. We're going to have to configure it for 24-volt input, which means that second dip switch would be turned on. And then we can look at the wiring. We should be able to make sense of it knowing the functionality of the terminals outside. Now, again, this is a conventional single stage furnace. You can do this with two-stage furnaces, oil furnaces, a whole variety of equipment. But let's look at their notes. This comes from Carrier's supplemental installation instructions, which you see right here. They can be found online at hvacpartners.com. All right, so let's look at their notes real quickly. They list some furnaces, 59SC, probably the one we're most familiar with. We already know that the reversing valve needs to be energized in heating. Y1 terminal at outdoor unit is optional. However, if we only have one wire, we're going to land it on Y2. We're going to use a dual fuel thermostat, and we're going to configure that thermostat appropriately. Refer to indoor unit for additional information. The only additional information that we would need to refer to would be the dip switch on the outdoor unit, SW or S1-2, as you recall. We turn that on to tell the unit that we're using 24-volt conventional wiring outside instead of communication wiring. And then the functionality is pretty straightforward, right? Obviously, we've got R and C going to both our furnace and our outdoor defrost control. We've got G going from the thermostat to the furnace. We've got our call for heat going directly to the furnace. And we've got a call for compressor going from the thermostat to the furnace and then to the outdoor unit. Obviously, this will initiate appropriate airflow. And then this will tell the compressor to come on. And then we've got our reversing valve. I'm not going to get into the configuration of the indoor equipment because every piece is different, but I will say that we need to configure the indoor piece appropriately to provide nominal airflow for our heat pump. And we'll look at an example now with a conventional fan coil. In this case, the FMA4. So again, R and C between thermostat, indoor equipment, and outdoor equipment. Let me go back real quickly. On the furnace, notice that we are not using the defrost terminal. We are not sending a coil into the furnace to bring the furnace on during defrost. When we do that with hybrid solutions, we can oftentimes introduce the potential for high pressure faults coming out of the defrost cycle. And so Carrier has recommended that we not do that. If we so desire to do that, that would be up to you. It would, in all likelihood, require that a bonnet sensor be integrated into your installation. All right, now, coming back to the fan coil, we can see now they do use D, and that's because they're assuming there's a backup electric heat package, and that's appropriate to run during defrost. It's not going to cause us any issues. So, again, R and C straight through, G from the thermostat to the indoor piece of equipment. Our backup heat call, probably labeled AUX/E on most thermostats, comes in here to W. And then our defrost terminal at our outdoor unit will also come in here to W to initiate that same piece of backup heat during defrost. Y is going to go straight to YY2. If this was a variable speed fan coil, then you may land it on your indoor piece of equipment as well. If there's a terminal, this would be a fan coil that does not provide a terminal for compressor operation. But if you did have a FV or something like that, where it did have a Y/Y2 or a Y1 and then a Y/Y2, in this case, you'd land it on Y/Y2. And then, of course, your reversing valve terminal will go outside, land on the B terminal, and needs to be configured, as they already said, to energize in the heating mode. Okay, guys, so that sums it up. I know it's brief. It's just a quick introduction to sort of some of the common questions, stumbling blocks for these types of installations. Just want to reiterate that this outdoor unit, although it looks like a ductless unit, is effectively a horizontal discharge, inverter-driven conventional heat pump with a defrost control outside. It can be paired with its proprietary 40 MUA air handler. However, it can also be paired with conventional indoor equipment that includes single and two-stage gas furnaces, oil furnaces, conventional air handlers, and any other options that you might find out in the field. So the big points here are understanding the terminal functionalities and the dip switches, and sort of cutting through the fog of all of the different potential options you have. You're wiring this at 24-volt conventional, which is, again, our recommendation. Really, all you need to understand are the dip switches and the terminal functionality. So reference the manual or reference this presentation for the dip switches. Reference it for the terminal functionality. The big ones are that the reversing valve energizes backwards from what we're used to, and that D is our call for backup heat during defrost, not W. W should not be used, okay? So those are the highlights. We'll look forward to putting out a full video live that has the equipment on hand, shows how to configure it for upflow, downflow, horizontal, left, right. Goes into a little bit more detail on the overall installation. But these are some of like the frequently asked questions that we get that we want to make sure everybody's up to speed on, and get you up and running with these so that you're not waiting around for us to put a video together or waiting for us to come do individualized training. So if you need the training now, hopefully this suffices. So again, Austin Dillon with Pierce Phelps. Thank you very much for taking the time to watch this video. And as always, if you have any questions, please feel free to reach out to me directly. Thank you very much.